Qualys has brought together vulnerability management and patch management, letting security teams discover vulnerabilities and apply patches immediately, all within a single, unified app. Sign up for a free trial of Qualys VMDR, vulnerability management, detection, and response today at securityweekly.com/Qualys. The average large enterprise has 24 million vulnerabilities. The good news is only 5% will probably be exploited. But which 5%? That's where Kenna comes in. Kenna Security's modern vulnerability management technology combines real-time threat intelligence, data science, and automated risk analysis to prioritize the vulnerabilities that pose the biggest threat to your organization. Team up with Kenna Security and make the most of your limited resources. Learn more at securityweekly.com/Kenna Security. The biggest problem in security that remains unsolved is flat networks inside the cloud and data center that allow threats to move laterally and compromise vulnerable targets. But microsegmentation using traditional firewalls is too complex and time-consuming. There's a better approach: Edgewise Zero Trust Auto-Segmentation. Edgewise is impossibly simple microsegmentation. Using the identity of machines and software that are communicating, Edgewise offers the strongest protection that adapts automatically to changes. Protect any application in any cloud without any changes to your network by visiting securityweekly.com/Edgewise. Welcome back, everyone, to Paul's Security Weekly. We've got some webcast and technical trainings coming up this year in September. Find out why traditional data security can't be zero trust and learn how to reduce the blast radius of your cloud infrastructure. Visit securityweekly.com/webcast or /on demand for previously recorded ones. No stranger to the show, Sumedh Thakar is the Chief Product Officer at Qualys and oversees worldwide engineering, including the DevOps at Qualys, which he's here tonight to talk about. I'm so excited. Sumedh, welcome.
Thank you so much. Always a pleasure being here and talking to you guys.
Yes. We've also had Joff Thayer, who joined us. Joff, welcome.
Hi, good evening. It's good to be here.
Yes, very nice. So, Sumedh, you have kind of teased us a little bit about DevOps, how we apply DevOps, security to DevOps, but also how Qualys is implementing DevOps today. And I'm hoping for like a little bit like what goes on under the veil at Qualys and how you're doing the DevOps process and applying security at those various steps.
Yeah, so we actually did a lot of work on our platform the last 4 or so years, essentially going back, early back in the day, and our history. We started before cloud was fashionable. Everybody now uses it as a fashion statement, but back in the day, we used technologies, PHP, Oracle, etc., that was available to really build a multi-tenant platform, which was pretty innovative at that time, and what happened over the last few years is as we have expanded that platform into many other areas, getting into patch management, EDR, collecting large volumes of data. Like we're collecting, we're indexing like 6 trillion data points in Elasticsearch today. So we realized a few years ago that we had to go through our own digital transformation and get out of that more monolithic PHP Oracle stack that we had, and move towards being able to do microservices and create a platform where we can add functionality much faster, because that we felt was very existential to basically our product and the platform. We really needed to make those changes, and so we went into that really bringing in the new practices, being able to do DevOps. And that was very natural, because being a SaaS organization, you really are always in that mode of iterating fast and creating new functionality and smaller chunks and pushing it out quickly. And so we were always looking at how can we make this process better. And that's kind of what really pushed us into that journey of having our development team do more and more automation, so that we had less and less manual effort being done by the IT operations team that was deploying the product. And so we really kind of took a big plunge into that whole DevOps movement. And I think that really has shown how quickly we have been able to innovate and bring new capabilities to the product. So it's been a very interesting journey, looking at the silos that existed and the changes that we had to make DevOps successful in the organization.
When did container, I mean, obviously Qual is very forward thinking with cloud. When did container start to enter the mix, and what was that like when you made that kind of shift into assuming, container based architecture?
Yeah, I mean, about 3-4 years ago, actually it's pretty well tied into the thought process of moving into the cloud, or when you're doing this re-architecture, this is the question everybody kind of goes through, right? Is how am I going to do? Am I going to do VMware on-prem? Am I going to go and move into the cloud? And adding containers and the ability to micro-segment the various processes was critical. So we were definitely going to go forward with containerization, and that had some resistance early on because people didn't know about it and they didn't know how it was going to function. But we pretty quickly realized that containerization was going to give us the ability to go bare metal, which for us as a SaaS provider significantly saves costs, so we could actually move into more of a commodity hardware that would allow us to expand the capabilities without having to pay significant amount into very specialized hardware, as we've had to do with Oracle or VMware or some of these providers that provided more of an enterprise capability. And so moving into containerization, we struggled initially because there was not enough information out there and how we make it successful. We went with Docker Swarm, that didn't really quite work out as well. And so we moved to Kubernetes. And so that's been an ongoing journey. But it was really sort of a revolutionary thing for the team to go that direction. And, I was kind of thinking, well, seems just like multi-threading, right? Like we went from a mainframe that did everything to Linux distributed computing. And then from there, we went to like, oh, maybe we don't need so many machines. We need just virtual machines. And then from virtual machines, we moved into like, oh, we need to have multitasking on the same box. And then multitasking went to multi-threading. And it just seems like we keep reinventing the wheel. But the idea that you can use the same machine to have different containers running on it is not necessarily new, but just implemented in a different way.
Absolutely. What are some suggestions that you have based on your own experiences, building it out at Qualys, of the different points you can add security in the DevOps process, right? Like, do you start with the static code analysis in the developer IDE, and then do you move to SCA? Do you move to dynamic testing, use your own product to test those containers before they go to deployment? Like, what's the journey from we're going to start writing code all the way to like it's deployed in production?
Yeah, we sort of had a pivotal moment when we realized, and I got one of these reports. We're a FedRAMP certified platform, and so I got one of these reports where somebody spun up a virtual machine in the infrastructure, and it had vulnerabilities from like 2 years ago that showed up in a scan, and we were like, how is that even possible? Like, and we realized that the processes where these virtual machines that were forming the base of the platform were built like a while ago, and people just basically did that thing completely mechanically without thinking through, and they would just take that virtual machine and they will spin it up, and then somebody will go in and they will spend hours patching those systems, and that they would do it over and over and over again every day. And then we were like, well, this doesn't make any sense. How can we essentially do everything that we can to eliminate as many security issues as we can in the DevOps or in the development journey before it went to production, right? So the earlier model was developers didn't really necessarily care about security. They wrote what they had to write. They threw it over the fence, and now it was up to the IT and the security team to figure out how to secure it. And so the first thing was, well, put a firewall around it, and then you do vulnerability scans, and you keep patching the same stuff over and over again. So the real thing that really pushed us in that was let's basically have a motto inside Qualys, which is, irrespective of the tools or the vendors or whatever it is, we are going to do everything that we can to fix every possible issue in a development before it goes to production, because that meant that we had less things to do and worry about, and more important things to worry about in the production environment. So we were not spending our time patching machines.
You say that like that's not a common practice for software development.
It was it was definitely a mind shift change, right? Internally, people, and it was very interesting because people were very excited about DevOps because they were like, oh, we're going to eliminate that IT and the security team. And we're just going to, like, my code, I'm going to write it and I'm just going to push it through the pipeline and it's just going to show up in production. And that's all well and good, except that now when there is a security issue, you cannot blame anybody else, right?
Yeah, you own it now.
All those teams. So now it kind of, there was like this epiphany after a year of doing this where people were like, well, I guess we need to be responsible for our own code. And so we kind of got into developers saying, okay, we're going to engineer security into the overall pipeline and do as much as we can early on to eliminate those issues. So that helped us move to a model where we were building images with all the vulnerabilities fixed on almost a daily basis, right? So we're not using old virtual machines to spin up images and then going back and relooking at the same vulnerabilities over and over again.
Yeah, and I love this philosophy and approach, and it's more than just a technology shift, right? Sumedh,
Right.
you said it's a mindset change, right? That every time, and we do this here at Security Weekly, right? I mean, we're much smaller, right? Like one developer, as opposed to hundreds, at Qualys, right? But the same principle applies in that every time I spin up a new development environment or I rebuild my containers locally, it goes out and it pulls down all the latest software libraries, all the latest updates to Linux. And guess what? If something breaks because we patch something organically just by rebuilding the container, now as a developer, it's your job to fix that before you go check in that code, before it goes off to testing process, before it goes into production. Like, let's just fix things as we go. And it sounds like you've adopted the similar mindset, right?
Yeah, and that was a focus. And then we started breaking it down to say, well, there are certain areas that are more on the image side. There are other areas which are more on the base image for the virtual machine itself. Some are on the container, some are on the application, right? Like, I mean, it's one thing to have it, but then when you put your application, how do you make sure you test it and as many ways? And the one thing that came out of that also was that you can't have that speed of doing this if you don't have automation in QA.
Yeah.
So you can't patch your machines and stuff every day, pull down the latest software, etc., if you don't have a way to do a massive automated test of the entire functionality, because otherwise you're going to just break things, right? And I think that's something we learned quickly and we put in place like a way to be able to test any changes that we made in an automated manner so that we reduce the time it took us to certify this thing before it went into production.
Super important point. Yeah,
Jeff.
So I have a quick question.
Oh, Jeff's got a question first.
All right.
Oh, okay. Jeff
All right.
first.
Jeff and then Joff.
Age before beauty, Jeff. So this is sort of a two-part question. When I first came out into the private sector back in the late 90s and we were trying to, teach basic security to how to build a security program to companies that were venturing onto this newfangled thing called the internet, I swear we used to teach about software development life cycles and building security into every step of the process. You make it sound like this is a new idea, and it's always been that way. My proof point, part two of the question is, it's in the PCI standard, and you knew you were going to get a PCI question sooner or later, but PCI requires you to build security into every phase of a software development lifecycle. So to put that in the form of a question, a DevOps question, it seems like the DevOps world, not that anybody seemed to ever follow a software development lifecycle, but they seem to embrace that they could abandon that. At least that's one way to interpret, or at least one way I interpret what you're saying. Why is that? Why do developers think that, we finally have a reason why we don't have to follow a development lifecycle? Any thoughts or comments on that?
Yeah, I think it's not quite that. It's basically you shorten. I mean, you remember the waterfall and the agile battle back in the day, and we ended up basically just doing mini waterfalls because agile ended up being like too much work for us. And so you have to do whatever fits your way that you develop. But the idea there is that you don't short circuit the software development lifecycle, but you go beyond that. So while you still have to do your design documents, and you still have to do your code review and your QA testing and your unit testing and your integration testing. It used to stop just at that, and the developers, they didn't really look at security, and they then threw this thing over the fence. And you remember that from the time that you actually had a functionality in the product to the time that it actually went out into production would be a month or so, because of all the various processes and the certifications and all of that. And the desire to innovate faster got people to say it's not that we're circuiting necessarily this as software development lifecycle, but short circuiting the various processes that follow it, right? Like getting the builds done, getting those builds pushed out manually to the different servers because you're using rsync, etc. And then manually somebody had to go make the configurations and one by one enable the servers, and you had to have a big downtime. So the automation that the DevOps revolution sort of brought together was allowing developers to also define in production with code how this thing should deploy, how this thing should work. And I think that is more the way I look at that is it's not that we short-circuited SDLC, but the DevOps thing brought an automation mindset. So while all of this was always required by all standards, there just never really was any good means to do this to the extent that we are able to do today because of the realigning of the pipeline and the realigning of the way the builds are done. And also containerization brought about that notion of breaking down monolithic functionality of a big application build into smaller individual services that you could quickly iterate and then push out. And they had a much quicker time in the way you can build and push them out, and they were not dependent on each other. And I think that's sort of the combination of those things pushed more towards automation and is making DevOps something that people are looking at that as a way to really speed up the end-to-end process and not just the development lifecycle.
Well said. Joff, you had a question.
Yes. So my question is really trust in the stack. So, as a security professional, I've watched over time as we have essentially migrated trust, the trust boundary, kind of up the stack, right? So as we get into containerization, we are trusting more and more that the layers underneath us are built appropriately and that, we won't see some sort of flaw or vulnerability in those layers below us. So my question to you is, how far do you extend that trust? If you look at Docker Hub, for example, and you bring in like a Python Alpine build, or you bring in an Ubuntu-based image, can you trust it? Or is your philosophy, without giving away things you shouldn't, is your philosophy just to bring all that in-house, build your own repositories as the base, and then scale up and scale out from there?
Yeah, so I think you have to have the trust and verify, right? So I think it's a good, to me that there's Docker Hub with all these images are a little bit like open source, right? You can basically bring this code as part of your application, and that's sort of what we do is that we leverage, somebody has built a good image for a base image that we can bring in, whether it's Docker Hub or wherever it is, we will bring that in. But then we do put that through our testing as part of the overall testing cycle from a security perspective as we are building it, right? So we won't do that as something that we just blindly trust. Of course, unless somebody came up with a repository where it was very well certified images that were available, and then you could trust that, a little bit like your mobile apps, right? Like if you got an app through an app store, you felt much better that this was a certified app because Apple, looked at it, etc. Versus if you're just downloading an APK and trying to spin something up. So, I think it's a little bit like that, where it's good that it's available and it helps, but I wouldn't trust. I don't trust that directly to use it as is. We do make sure that we do our own testing on those base images before we put those in.
And I think the benefit for Qualys customers and Qualys itself is that through acquisition you acquire some great technology, because we know the team at Layered Insight, right? And I think whether you build it yourself at any level or get an image of any kind from anywhere else, it still has to go through that verification process, right? And those features are built now into, obviously, right, the Qualys platform, correct?
Yeah, exactly. And I mean, as that thing has matured, right? Like security in DevOps, and I don't really like to call it that the DevSecOps, because I think it's more about still DevOps and automation. Like you don't say like Dev QA Ops or whatever it is, right? Like it's really built in there. It has to be part of that. And so the security processes in DevOps have also matured, right? We've gone through. Initially, we were just doing image scan, and then we added the ability to do software composition analysis, application security, etc. So the more we can do across these layers, the more we feel like, for example, we're not doing configuration drift monitoring, and so we started adding configuration checks as well as part of our CI/CD pipeline, because that was always the number one issue that you had, is that somebody went in production, manually configured something, and now a bunch of stuff broke because they put the wrong preference key or whatever it is. And so I think that's sort of the journey, that as we have matured, we have been adding more advanced capability into the stack, and you have to basically let the development team. So the way we do that is the security team needs to provide the policy, right? So that's kind of where we draw the line, is how do you do the trust and verify? Is the development team can decide how they want to build something, how they want to do the automation, but then there has to be these security gates that are put in certain places along the pipeline, where the policy of what passes or fails. As an example, right, the developers could use Jenkins or whatever it is. They can bring that image from wherever they want, but then the security team basically defines that the build will not succeed unless this scan happens in between the build being kicked off and being pushed out to your Artifactory, right? So that process is where the security team comes in and say, we're going to use this tool in the CI/CD pipeline, and this is the policy that's going to decide whether this is going to be approved or not approved. The developers can do whatever else automation they want in the pipeline, but then that gate has to be passed before they can go to the next level. And that's how we inject that security in a few places. So that way security is at the table, and they are defining the policy, so that developers don't just say, okay, I'm just going to remove this vulnerability from the requirement because it's not passing, right? So there is still that check and balance that we can put in the pipeline.
It's interesting, Joff talked about trust, and Sumedh, you talked about automation, and it's very key to the DevOps process. And I find that one of the challenges that many struggle with is, once you've got this more complex system, you've got systems that implement your CI/CD pipeline, you've got the application itself that's being deployed from that pipeline, and that really brings forth the requirement of the ability to manage secrets, right? Because things have to happen automatically. It means things have to trust other things and use secrets and passwords and keys. How do you manage those without giving away, internals inside Qualys, right? But general advice, how do we manage secrets? What's your advice there?
Yeah, and this is part of the re-architecture that everybody's going through, right? And this is the difference between a lift and shift, digital transformation, where you're just saying, I'm going to take my virtual image and then put that out in the cloud, versus truly looking at how do you re-architect your entire service so that secrets management, etc., configuration management can be done in a seamless way from using a centralized architecture, right? And so today we leverage vaults, obviously, and a few other methods, but primarily the ability to have these vaults where we use these tokens and we share these secrets between various applications, so the trust comes through the vault, but the actual values of those keys are then set by the operations team in production, so that the developers are not the ones that are, because you'll find that, right, they've done something, they put it on GitHub, and then that same secret that they have checked in, which is open to public, is being used in production environment as well. So that's where the automation comes into play, is that in the pipeline, when this thing is available and ready to go, the operations team has to go in and they have to be the one putting in the values for these secrets, etc., so that we have that sort of some separation of duty between these two teams, and then you can essentially achieve a better security. But today, vaults are really the way to go when you have a new microservices architecture, because they do provide you a robust way to manage your secrets and manage your trust. And this is important because microservices, you break down everything into so many services, and they all have to talk to each other, and there has to be a trust between those, so that you won't be able to bypass that and just start to have a rogue service trying to call another service to get this information.
Mm-hmm.
Yeah, so I just wanted to make another comment, if you don't mind, Paul. Just rolling back just a few minutes, but to the misconfiguration or the configuration check comment, that's really, really important, because as a pen tester in the industry, one of the really probably most critical things that we take advantage of, I'm looking for words here, but one of the most common things that we take advantage of is misconfiguration. And so if you build in configuration checks into the CI/CD pipeline, you build in those checks as you're going through your process, you have the potential of eliminating that avenue of attack that is in fact more common than even straight up software vulnerabilities. And I think, Tyler and other pen testers I know in the industry, we can tell you right now, it's not really that often that we use a traditional heap overflow or stack overflow or one of these traditional machine-based remote attacks anymore. It's more misconfiguration-based than anything else.
Sloppiness leads to misconfiguration.
We could have an entire other conversation about this. This is like a area that I really feel passionately about, because I totally agree that too many times people in their silos focus only on the traditional vulnerability management as a way to say, oh, I've patched all my software vulnerabilities, but their configurations are so horrendous that in many ways they are more susceptible to being compromised because they have misconfigured their systems. They don't have network level authentication enabled. They don't have these other things set, and much more likely to get compromised. And so I always find that really, funny is that some of these vendors, when they talk about, they have this exposure score, this, that, based only on vulnerabilities being fixed. You have no idea, the kind of bad stuff that misconfigurations bring about. And in many ways, it's much, much worse than a software vulnerability, because it's so much easier to take advantage of a misconfiguration, which tends to happen all the time when you use manual processes versus automation. I think that's really fundamental thought process there, is that these configuration issues are really as important or even more important than your software vulnerabilities. Totally agree with you.
And it's interesting too, like in terms of a patch versus a configuration, in terms of impact and difficulty to fix once it gets in production. I've found I would rather make those configuration mistakes early, fix them and adjust everything, because once that gets into production, now I got to go make that configuration change in production. That's almost worse than me trying to patch software in production, to be quite honest.
Yeah, absolutely. And that kind of brings, that there's just overall the importance of some people go just the extreme, like, we're doing security in our CI/CD pipeline, so we don't really need to do anything in production. I literally was on a call with a customer today who was telling us that, I scanned my images, so I don't need to do anything. And the number of times developers who will work around that by creating lean images, and then as soon as it spins up in AWS, they'll download a vulnerable Java or library or something from an S3 bucket, and then your machine is suddenly vulnerable. But you need both, right? And the idea is that for us, when we moved to this process, it really eliminated like 60% of our patching needs in production were eliminated, because we were reducing misconfigurations and vulnerabilities going out, and our teams could now scale up to be able to do a better job of monitoring compromises, etc., in production environment, rather than just spending all their time trying to fix those misconfigurations, right? I mean, it's like a and it's a lot like a car, right? When you buy a car, you don't go buy a Mercedes or whatever it is, and then you go to another store and now you buy a seat belt and then have that fitted, and then you go somewhere else and then you go get parking sensor or whatever it is, a collision sensor, and then get that fitted. You the security that is needed for that thing to run, like an application, is already built in, comes completely built in. And that doesn't mean that at runtime, you don't need a technology that is monitoring distance between the cars and all of that, but you essentially need both. And the more we get that done in the production or rather manufacturing phases, I should say, the better it is to focus on other issues in the production environment.
Hey, so I got another question. You had commented on the observation that I've made and many other people have made, is that containerization is really good at offering you the ability to perform essentially micro segmentation in your application, right? To build up little containers to do specific jobs. Can you comment kind of on the balance between that micro application architecture or micro segmented architecture versus the security, and is there a space where you see it's going to go too far into this sort of micro segmented application architecture?
I don't think from a security perspective it's that much of a deal, but at the end of the day, right, it's a good question, right? I mean, good architecture, you have to find the balance, because containers do have overhead, right? Like if you take a box and you run X number of containers, there is a certain amount of overhead to run containers. So it's significantly lower than running multiple virtual machines. But so if you break down your containers and microservices down to little functions, and you run each of them as a microservice, as a container, that is going to cause you a lot more overhead in terms of just being able to run the additional services, etc., that's needed from the containerization platform to run that. Versus if you find the right balance, then you can have. I mean, really, it comes down to that it's a microservice, so you should break it down into something that offers a service as a unit rather than an individual function or a line of code or whatever it is. But there is a need for that as well, and that's why you see something like Lambda come up more, because people want to break that down even more into functions and be able to use that. But that's a different type of a platform, and I think that is up and coming, where in some cases you're going to have even more breakdown in terms of how small you want to go in the functionality when you break it up. Now, I think in general, I feel from a security perspective, anything that you break it down into its smallest unit is better for security, because it's much better and much easier when you have a defined input and output and a smaller amount of functionality, because then you can do a much better job at protecting the input and protecting the output, and being able to put the right security tools, because it's a limited functionality, and that's what you need to worry about. So I think from a security perspective, the better defined interfaces you have, the better it is and easier it is to manage the security, versus a big monolithic application where it has too many entry points, too many exits, and too many different in paths that the code can follow internally. So we try to find the balance between that breaking down something and the overhead of just running these containers, because if you have too many containers, then the density really becomes an issue.
Oh, great answer. So yeah, my thinking was sort of drifting towards, how many trust boundaries, if you like, between containers can you actually manage and scale from a security perspective? But you can balance that by the fact that if there are these really discrete, well-defined units, that trust boundary actually gives you an opportunity as well to actually perhaps even inspect or have some sort of insertion point between those trust boundaries. So I think there's an interesting conversation there we're going to see evolve over time.
That's why the east-west traffic, looking at that actually is very helpful from a container perspective, because in general, if you know that this functionality or this service should only be called by this other service, it's much easier to manage that, because you have that trust boundary and it's a well-defined boundary, and you can manage it at the network level, through the containerization platform as well. And in terms of the boundaries in containerization, I don't look at the count as much, because when you go into microservices and containerization and leveraging that mechanism, you are automating. You cannot do this manually. So if you are doing automation, and then at point, whether you deploy 10 trust boundaries or 25 trust boundaries, it's all done via automation anyway. So it's more about, how do you build the right mechanism and the layers. I mean, the security has to be done in layers. That really doesn't change, no matter whether it's containers or cloud or whatever it is, right? Like you still need to have the right trust being used from the vault perspective. You need to have east-west boundaries from a microsegmentation perspective, which of course becomes easier when you have services where the service is only supposed to do one thing, and it's supposed to fetch the data from this Elasticsearch node, and now that only one service is allowed to call this service. You can manage that much better.
Yeah.
Sorry, Jeff had a question.
Well, at this point, probably 3 or 4, since my hand's been up for quite a while. To work backwards, your description of making it easier to secure code by breaking it down into smaller pieces and smaller parts, that seems intuitively to be just better code anyway. The smaller you can make it, the more you can get your arms around it and make it work better and function better and more efficiently, and also cover the security things. It just seems like the more complex things are in general, the harder they are to make them work and not break, yet alone be secure. I wanted to go back, though, to when we were talking about misconfiguration being sort of the Achilles heel of most organizations, which I too agree with. But I wanted to ask, because we several of us sort of touched on a little bit, but intuitively, what's the opposite of misconfiguration? A good or secure configuration? And my question was simply going to be, how do we teach organizations to get there? How do we do it in an effective, comprehensive, across the board manner? Because the pen testers will tell you, they only have to find one misconfiguration in any obscure place to be successful, to win. Because you work at Qualys, I suspect you're going to have a certain perspective on this, but I wanted to just ask the question, how do we get people to do the opposite of misconfiguration consistently, which would be do good configurations, secure configurations?
I mean, I don't want to go back to the days when I used to code, but I remember other developers in the team who used to, there was no standard for configuration, right? Like my application wants to talk to the database, and I'm just going to save the password, in a file in the root directory of my code and just use that. And that's how I got my credentials to talk to the database, as an example, right? And I think that the more you break these things down into trust boundaries and microservices, and the more you re-architect the overall application and the platform to have vaults and use more technologies like that, the better the architecture is going to be, right? So today, more and more, the newer developers, they really just take it for granted that they're going to use trust boundaries with being able to use vaults, etc. And I think that's an education that needs to be done and needs to be part of the architecture. I mean, there was a comment earlier about how security in SDLC has sort of always been there. It's always been there in a document that you expect the developer to read on day one when they join, and then there was no real good way to sort of enforce it. But I think when the architects are re-architecting these applications, they define these trust vaults and how they should be used and where information should be saved and how that should be done. And typically the misconfigurations were happening on the operations team side, not so much the developers, right? Because the developer will say, go install this on 50 servers, and each of those 50 servers need to have these configuration settings that I'm going to read from this particular file. And the struggle always was, how are we going to get this to 50 places at once? How are we going to? So a lot of times, people would log in, they would manually update the configurations, etc. So I think leveraging the microsegmentation, leveraging the new way of doing the architecture, and then the automation, the only way I feel like you can defend yourself against these misconfiguration is to eliminate the manual processes that go into making these configurations, because that's really where the issue happens. Oh, I forgot that. Oh, I put an extra semicolon, and so now the line is ineffective and it didn't take effect, etc. Right? So the more you can do this at the build time and an automated process, that, and which is really cool thing now with Docker, etc., is you can do these rolling upgrades. You don't have to do anything. The system does it for you. You just say, here's a new image, and then in a manner of rolling upgrade, bring this machine down, bring it back up with a new image, and then put it back into the service. And this is where you used to have so many errors happening in the past as well. And so I think that leveraging the automation capability is, I feel like, is one of the only ways you can really eliminate or reduce these misconfigurations.
Yeah, you had me when you said standard. Because that's the answer that I was looking for. There needs to be standards that are followed for whatever it is.
Yeah, but also, Sumedh, it sounds like reducing the opportunity that you have as a developer or ops person to introduce a configuration error, right? Reduce the risk of that. Yeah.
Exactly.
But
I mean, look at what people move to the
Larry,
cloud has not reduced the number of compromises. They just have shifted. You have your S3 bucket, so you don't need to update the software. But how many times do we see somebody misconfigured their S3 bucket because they manually logged into the console, made some changes, forgot about it, didn't realize? So things you used to have more with firewalls, now you see those with PaaS services.
And you really have to go out of your way today in AWS to make an S3 bucket public, to be honest, right? Exactly. They made it really hard, and people still do it.
But that doesn't even have to happen, right? I mean, I've been on tests in the past where people have accidentally left, Subversion repositories, and this is going a little ways back before Git was as popular, but Subversion repositories on public web servers where I've downloaded S3 keys, and then all of a sudden I'm talking to the S3 buckets, right? Just with a little bit of Python code. So I think Sumedh has really, really, really good point. The fact that you can automate the standard is probably the most powerful and useful thing of the CI/CD and containerization pipelines that we've got, because you take the decision of just writing a file out to some temp space, or having some sort of insecure mechanism for loading a key or a certificate or something. You take that out of the developer's hands, which I think is huge.
And the way you can enforce some of that is, like, for example, certain parts of our infrastructure, we actually disable sysadmin login to those machines because there is no reason.
Right.
All patching and all configuration updates now should happen automatically. So we even eliminate the possibility for somebody to be able to log in and actually do something manually that can end up, causing that machine to be exposed externally, because the automation has become so solid and so pervasive.
Yeah. So in some ways, Jeff made a comment that complexity is increasing, but I don't necessarily agree. I think in some ways the increased automation.
That's not what I said, Jeff.
Okay, paraphrasing.
I said complexity increases the likelihood of insecure and inoperable software.
Absolutely right. But in some ways,
in a manual environment, yes.
Yeah, in some ways, I think the automation, though, actually enables us to simplify some of these processes ultimately in the end, which is an advantage. I mean, yes, there's additional complexity in the back end that could introduce potential vulnerabilities, but that's concentrated in a potentially a smaller group of people that are more focused on that particular issue. So I see nothing but opportunity and advantages to the world in this space. In fact, I wish it had happened 20 years ago, to be honest.
Well, we had to know what was bad for us to know now what is good, right?
Then I wouldn't have a job? Oh, no, man. Come on. Yeah. We're all riding waves in this industry. We'd all have a job somewhere.
I wanted to ask Joff and Larry, our pen testers, what's the ratio of misconfigurations that you guys trip over and use on your jobs that are, OS hardware type based or more, traditional applications, database and things like that versus software things. But then I thought, well, given that the whole world is becoming software, including network and firewalls, anything that's cloud based, is all software anyway, so it's probably moot to even ask the question.
No,
But I was curious.
It's a lot.
at the time.
It's a lot.
It's a lot. Yeah, well, and much of the infrastructure is code, and I think just touch on the configuration thing. Sumedh, you almost made it sound easy, right? But the critical component to this process is automating your testing. So
Yes.
if you've got a new library, you've got an OS update, or you've got a configuration change, yes, that can be done quickly, but it all goes through an automated testing process. And if you don't have that process, you're not much better than you were before, really. Even if you built out other pieces of your pipeline, that testing is critical. So, Sumedh, I was wondering if you could talk about advice you have for those of us that are working on building that automated testing.
Yeah, I think if you look at now how patching is being done, right? You today have the opportunity to never have the need to patch a server in production, right? If there is a vulnerability that is discovered on the build, I talked earlier about how you can have rolling updates, etc., and rolling restarts of the systems. You can actually build a complete automation where when a new vulnerability is detected on an image, that image will automatically, or that process will automatically go out, pull in the newer patch version of that particular software library, rebuild the image, and push that image out to production without any human being involved in this process. This can be achieved for quite a bit of software that is out there because the way these vulnerabilities are now published and the newer versions are available, etc. Except the biggest question is that of trust, right? Well, as soon as I bring in a new library and I rebuild the image, is that going to break my application?
Yeah.
And the only way you can actually do this is with automation in the test process. So we put a lot of emphasis and learning from our failures, of course, we put a lot of emphasis on building an automated test bed where you can have this automation completely test your entire end-to-end application in a very finite amount of time and covering more and more use cases. Because if you don't have that, first of all, the automation is the only way that in a short period of time you can cover thousands of test cases. If you want to have humans do that, it's not going to happen. It's not going to be consistent. You're going to have things, what will humans usually do in a short period of time? They're going to sample. They're going to do sampling of the test cases and test some of those and push those out. So just that hiring a team and being very, very focused on building automation test bed really helps and is a critical component if you want to do this automation of security in the DevOps pipeline. You want to be able to test all the changes because then you can do it in an automated way, right? I patch the machine, I pull in a new library, automatically rebuild, and now I push that image to my test farm. An hour later, entire testing process has gone end to end. Nothing was flagged. So I feel comfortable pushing it out to production and that everything will work correctly.
So is your QA team now just another development team?
Yeah, I mean, today that's why they don't even want to be called, quality assurance. They want some sort of a software developer in test or automation engineer or something like that. Right? That's even the terminology of just calling them quality assurance or QE is changing quite a bit because more and more focus is being pushed on. You have a smaller team that is doing the functional testing of new functionality in a manual way, but every functionality that they test, they need to add that as an automation test case into the big test suite that we have. And so that way you reduce, we almost flip the ratio from where in the past you had a big manual testing team and a couple of people were focused on some automation to now having a few people who are doing the manual testing and a much larger team that is just essentially doing automation and testing using automation.
Yeah. No. And what are some of the other like organization and role-based changes when we go in this shift to, we call it digital transformation or the shift to DevOps, right? There's a lot of technology changes, but there's a lot of organization and role changes within the organization and how people interact and the different roles that they play. Can you talk about how that changed over time, Sumedh?
Oh, absolutely. I mean, we used to have a separate tree of QA people, a separate development tree, and then you have a separate operations people and, separate security team. And there was always the throw over the fence approach for everything, right? They would be like, dev is like, I've done my job, and QA didn't catch the bug, and that went to production. I'm like, well, it's your code. You introduced the bug, right? You can't blame QA for not catching it because you didn't do enough testing on your side. So one of the first things we did was essentially combine the dev and the QA teams into a single organization that was reporting to the director or the VP of that group. So they are responsible for delivering a working tested solution. And there's no more silos of saying, oh, the QA organization is a different organization. So the first step was to basically have under the development or that lead to have both dev and QA combined working together. So they are responsible for delivering quality and the code and quality, not just the code and somebody else for the quality. Then
right now, Sumedh, that doesn't mean developers are testing their own code, right? Because that was always my concern years ago when we were merging.
It does encourage that more, because when they are part of the same team, we start to notice that the developers are working closely with the QA teams to add the test cases that they are testing also part of that. So what happens is that now when the developer does some changes, they can use the test suite, automation test suite against their code quickly before they push it out into and check the code in. And so they are motivated now to add more automation to that existing automation suite so that they can test their own code much faster. None of the developers want to go and manually test anything. That's right. That's just in the genes. So, but then the second issue we had was the operations team, right? That was in silos, taking the code from development, and then they were going through a lot of their process and pushing things and all of that.
Works on my machine. It's Ops problem now.
And that's where it came from, because how do we publish your machine? Right?
Well, in that model, Sumedh, right, when it gets developed and then it gets tested, and you hand it off to Ops, and Ops has a problem, everyone's always like, well, it worked on my machine, right? Why doesn't it work on your machine? I don't know. It worked on mine.
Right, exactly. And so we initially, when we started DevOps, in fact, I had the DevOps team reporting into operations. And we quickly realized that they had no ability to understand how to fix this at the source, right? Initially, we thought, okay, we're going to have some automation team in IT that was going to help make this better. But then we quickly realized that, and we then folded the operations organization, IT operations organization, into the development organization and engineering head, so that we also had a DevOps concept where they are responsible for delivering the end-to-end. And then this is not some different team that they can blame to say, well, it worked on my machine and now I don't know what happened in production, right? You need to have that. So we definitely saw major shifts in the organization from what it used to be 10 years ago, maybe, to now, where just like a QA person is part of the team and a developer is part of the team, now a DevOps person is also part of that team, and they are responsible for their microservice and their code to make sure that it's going out to production. Now, the concept of site reliability engineering, SRE, came into being recently as well, again, to bring automation in the monitoring. So there's definitely major changes happening in the dev organizations. If you truly want to go in this direction of leveraging this automation and doing things faster, it's a different shift that's happening.
Yeah, Google, I believe, went through a similar kind of shift, right? And it sounds like in when you described your use case is very similar, is that rather than having all these different departments that had these functional areas, you made teams that are more functional teams, right? Where the members of the team have different areas of expertise, and they're all responsible for delivering a quality product, whether that's security, operations, quality of code, and they're working together rather than these different silos is really the lesson that I'm drawing.
Right, and that becomes easier, to our earlier point, when you have smaller manageable microservices. Because now a team unit is responsible for a contained functionality with defined interfaces.
Yep. And now, is security built into these teams, and also has a separate kind of role as an overseer for recommending policy?
Yeah, so that's an interesting breakdown, right? So we have security folks as part of the automation. So we have the automation team in the development organization who's focused on building security capabilities into the pipeline, into the product. but they are not the security team that is setting the policy. So that is still the more traditional isolated security team that is setting the policy of what should be checked, how it should be checked. So we don't leave that up to the developers, but then the security team, that part of the development organization, are focused on how to build the automation to get security tools and tests in there. But then the policy of what should be checked or not is done by the security operations team. And then they also are the ones who are now managing, or I should say reviewing, the signals that are coming out of the production security tools to see if a compromise is going on. This was very different earlier because the security organization used to be the one who was spending a lot of their time installing security products after you got things to production.
Right.
So you kind of had an entire engineering team almost as part of the security team who were doing their best after the fact to build in their security tools and collect all the data. And then you had the NOC team or the SOC team, which was the analyst who were then looking at the signals that were coming out of all of these different tools. And so that has shifted, where that security engineering team, what used to be a team that used to add these products after the fact, moved into the development organization. So they are doing it upfront. And then the security operations and the monitoring team are more focused on looking at what signals are being produced and what's passing and what's failing, and deciding the policy for the organization on where we are going to do the checks and how we're going to do the checks.
That's awesome. Super helpful, actually, for a whole host of reasons. Any more questions for Sumedh?
None for me.
Sumedh, anything that you would like to share on this topic with our audience tonight?
Yeah, I think I talk a lot with the CISOs and CIOs, and I think somebody said this earlier, which is really true, is that it's an opportunity, right? Being able to, when you're going through your digital transformation, don't look at lift and shift, really look at redoing your security and the architecture and building security into the architecture. And I think the cost that is going to be there to do that is going to be well worth it, because otherwise the cost of building security after the fact is just tremendous and it doesn't really work. And so we've learned from that process. And obviously that's why you see that in the Qualys product line also, a lot of our capabilities now have a DevOps component built into it, so that you can take, for example, vulnerability management. You can build vulnerability management directly into the CI/CD pipeline leveraging Qualys. We have the Layered Insight acquisition that you mentioned, Paul, is again providing the ability to instrument these images in the CI/CD pipeline. When you are doing your cloud configurations, you have that ability to do that in early upfront through automation built into that. So in general, we have customers that absolutely have automated end-to-end everything from their AMIs and the testing of those and putting the required security agents on that, to collecting the telemetry information and the analysis, etc. Right? And I think no matter what the tool you use, the idea there is that leverage this transformation that is happening right now and take the opportunity to really redo your security the right way. And you really want to focus on the vendors that are providing you true native CI/CD and DevOps capabilities, rather than the others who are just providing you a virtual machine that you have to take and deploy into the cloud yourself. I think that to me is the first red flag when a vendor comes and says, here's my virtual machine that you can run in your environment. Like that itself is like, okay, something is not right if I have to manage your service essentially in my environment. So that's, I think that's something that, I truly believe in, and we see that a lot with our customers, and really an interesting topic. Happy to talk more about that some other time as well.
Fantastic. Sumedh, thank you for appearing on Pulse Security Weekly. It was informative as always.
Always fun talking to you guys.
Absolutely. Folks who want to learn more and get a free trial, vulnerability management detection and response, VMDR, you can go to securityweekly.com/Qualys. With that, we'll take a short break, come back with the security news. Stay tuned.